So now to set this guy up, you drop this guy on here. Wow, that is an amazing fit back there. Holy cow. Forgot to tap these 1/4-20s here. We can come back and do that. Wow, look at that fit. That is just right on the money. I can barely feel that edge. I wasn't shooting for that kind of precision, but where this plate and this meet, it's just the faintest of edges. So you'll see when this one, this is a 4-inch one, this is going to need a piece of 1/2-inch plate under it, and that 1/2-inch plate will sit under here and support it. But I need to figure out where the three pieces are going to be that press against this. So I need all of this stuff. So here is the end that's going to go on here. And what I'll do is I'll set these up so they're a little, so that I have to go that direction for them. So this one, probably like right about here. And I guess I can just mark these holes. I'm going to probably be able to unclamp this. I would like this one pretty much on center line, but it doesn't have to be perfect. And so I think I can use a locating punch, because these are 3/8 inch holes back here, and I can use a locating punch to mark my spots. That gives me a little ability to tighten this guy out so that it'll fit. Actually, I could be even a little further here. That'll give me some more adjustment space, because I've got plenty of threads in here. I go almost all the way to the back, so that's great. So this is all the way extended out, and then it retracts that far, so I can pull this forward and out, which is one of the things I wanted to make sure I could do. And then we'll need these guys over here as well, somewhere like here, and one more on that side. And I just need to mark all these positions out. Then hopefully we'll get enough force out of these clamps here to be able to press the shoe plate into the webbing, which is the piece right here. So I'm going to clamp these guys in place. I'm just going to drop this pin down here and mark my centers. So the center one I want fairly close. Even eyeballing it, I'm very impressed I got it square, because I want it to go right down the center. And this looks like it's pushing straight into the pin, because this is the one that you're going to put in first. And then these other two are going to bend this thing to fit that shape, hopefully. That is the goal. Okay, I think we're good. Well, I'm going to drill these holes. So I'm going to release the clamps now, and I'm going to free drill these guys. Just sitting on some 1-inch blocks like I've got. I've got some more of this tooling plate, and I just use them as spacer blocks. Keeps everything nice, square, and parallel. That's awesome. So we just got to drill those holes, and then I got to tap them over on the tapping machine, just because it's 12 holes, and that's a lot. By the way, this is an inexpensive transfer punch set I got at Harbor Freight. Highly recommend you get one. They're very useful when you need them. All right, so just give you a heads up what I'm going to do. I'm using a center drill to find all these points that I've identified. Working pretty well. But to be accurate about it, I'm going to have to stomp each one and just make sure it's right on there, because I'd like them to be somewhat accurate, you know. Then we're just going to drill them. I'm risking getting hosed here by trying this one-handed, but I've got my tapping head set to 3/8, goes in at 150, I don't know, millimeters a minute or something like that. I don't remember what the speed's measured in. 300 coming out, so it's faster out. And then the depth I'm shooting for is 32. So I clean all the threads between each tap cutting session. I line this guy up over, push the top button, and I wait till that gets to 32 because I've checked and that's a good distance. When you let go of the button, it continues for a little bit, like that. And it comes out. And you're good to go. Just make sure between you clean all the flutes, because you don't want to get chip compaction in there and then have the tap break. Again, I'm using a spiral point tap so that it pushes the chips through, because these holes are through holes. All right, I went ahead and assembled this guy. So here's all the big heavy duty clamps. Can put a little over 5,000 pounds of pressure on the ends here. You set this guy in here, find the radius that is not part of the compound radius section. This guy has a key in it to match there. This is a 5-inch one, and that's what this is set for by default. Set this guy right like that. Hit the center part first. Follow with the side and the side. Run a bead. Pop these guys up. Flip the whole unit over, and I guess I'll show you by doing it with this one that doesn't have the spacers on it. And center, and clamp, and clamp, and run your second beads through there, and that should be that. Now this guy needs a piece of 1/2-inch material underneath it, and the 3-inch one needs some 1-inch material, so I'm going to make some spacers. I'll just cut up some tooling plate that they can stick under there, and that should be adequate. And that should be all we need. The top clamp piece is still an option, but I noticed the thickness varies a lot between these pieces. They said plus 12 thousandths minus 0 or plus 14 thousandths. I forget what it is. It's a pretty big margin. And so whatever you make one, it's either going to be sloppy or it's going to be too tight. It just seems like, anyways, it's got a problem. So hopefully this is good enough. And that's it. I think that'll be where the project is. We'll find out what the vendor thinks about it. And thanks for watching. Hope you find it useful. Hope to see you next time. They say no plan survives contact with the enemy. Well, same for engineering designs on first go. They never are exactly right. So it turns out that the customer did need a plate here to hold this down while they were welding it, because things were moving. They tried laser cutting one out of aluminum here, and it didn't work. It wasn't strong enough. The aluminum just bent. So we're going to use 1/4-inch steel. And the reason is as the welds, you lay down the weld bead, you've got molten metal. When it cools, it shrinks and it starts to pull things together. They had a similar problem with this plate moving up and down, spacing itself off the bottom after the first weld. So they want me to add 2 of these heavy-duty Wilton clamps like this. So I need to place them on here and get screw holes for the 2 1/2-inch 13 bolts that'll hold them down. And we need to make another one of these plates. And they want 4 holes in here to mount this to their welding table so that it won't move around. These clamps actually take quite a bit of force and end up making it so that if this thing isn't held down, it moves around while you're trying to clamp it down. So they just want it all to be easier. And I don't know, they may even be trying to add a robotic arm at some point. So we're going to make another one of these pieces. We're going to get some holes drilled for this and some holes drilled and countersunk to mount this plate down. But this thing's so heavy to manipulate with all this stuff on it, I'm going to have to go and remove all these parts before I go and start getting this over to the mill. So I need to mark off where these holes should be. Now this is an interesting design, this Wilton clamp. It slides in place, as you can see there. So this base piece, you can actually mount it and then slide this in after the fact. Now unfortunately, the back rear part of it, which adds the final total strength to it, is not on the plate because I didn't design the plate. You know, they need this fixture to fit this. Would have been nice to have a couple more inches in that direction. So when I place this guy down, It's going to be a little bit problematic strength-wise if they decide to crank all the way down. Hopefully they won't need anything like that. The beauty of this is it'll work for all the different size shoe plates that they're going to use. So I guess let's just get on to marking this. So I marked out my holes here, 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 and here for those Wilton plates, but this thing's so heavy and this thing's going to be in the way. So I'm actually going to take off all of these things and I'll put them back on. Fortunately, thank goodness for power drills, because a lot of screws with a lot of aluminum threads and aluminum. Now fortunately, importantly, I hand start each one of these screws before I use the power drill, because in aluminum you could cross thread pretty easily. So I wouldn't risk it. One thing I've noticed with this particular clamp, which is super heavy duty, I think they could have gotten away with something lighter, is that as you start to apply pressure here, it leans back. And that might ultimately be a problem. I guess we'll have to see about that. But yeah, the fact that it leans back is not ideal, because, and that's why they have this this ball and socket type end arrangement here, so that this can rotate to maintain pressure, but it kind of wants to push off a little bit as it tightens. Even if you get it dead centered over it when it starts, by the time you're done, it's not dead centered anymore, which I find problematic. But anyways. See, that pin was just sitting in there the whole time. But the beauty of it is as things try and push back, it provides a broad surface, or a much broader surface than one of these little bolts for the force pushing back on it. All right, so I probably won't show all of this, but we're just going to go and drill a 5/16 hole all the way through, followed by a 1/2 inch clearance hole, and then countersink the sucker. Okay, should be good. Now we're just going to take this guy over, tap the other side. Well, I guess it doesn't matter which side, but this is the top. So we're going to tap through this side and be right back. I need to make some shorter 1/2 inch bolts. These are currently 2 inches long. I need them 1 3/4. So what I've been doing is popping them in a 5C collet. Oh, they're tight to begin with. Look at that. Isn't that interesting? I already made one of these and it was pretty tight going on, but I thought that's because even after chamfering, the threads were a little gummed up, but that's just how they are. They are kind of tight, which is kind of interesting. Also makes starting easily. Let's see, should this fit? I should just miss. Yes, that's good. Oh, except I won't be able to chamfer with on there. Never mind that idea. So these are kind of tight the first time. Maybe it's the black oxide process, because they're brand new nuts, brand new bolts. So I'm going to part off the bottom 1/4 inch. These are alloy steel bolts, somewhat hard, not super hard. So cutting with a hacksaw kind of sucks. You can do it, you absolutely can do it. Okay, we're good to go. Now I just got to get the nut on and off, which before the nut was tight, and I think that's simply because that's how they are when they're new. And it's looser now than it was going on before I cut this, so I think we're good. Alrighty, So just pull this 5C collet chuck out of here, pop the bolt out, put the next one in, we're gonna do 4. All right, so let's reassemble this guy. Should be good to go. Taking a look at this, I made this the same size as the vendor did, but I'm thinking that if this rear section were a little bit longer, when this tried to lift up, it would give it much more strength because you'd have a lever arm pushing back. Right now, the lever arm is just the distance from here to here. Not ideal. I definitely think they should be longer, like out to here. And the fact they're only covering part of the curve, I think that's not a problem. I just think that other part should be fixed. Oh, look at, I don't know if you can see this. The amount that it's going to have to bend here, that's insane. This one is just another one out of their collection. Oh, that's insane. No wonder they're having problems. This is way different than the set they sent me originally. The amount this has to flex is like a good 1/4 of an inch almost. Wow. And there it is. Okay, so there's that. And then 2 of these guys should fit in like so. And you should just be able to snug them. If they really crank on these things, it's gonna bend them back up off of this because there's no rear support. But I think that's holding snugly enough. It's not actually sitting all the way on the bottom over here. It's flexed up a little bit. I don't know what you do about that. These things are kind of cheesy. It's almost like you need yet another one of these over here. Well, there you go. Now maybe that's it, the final thing. You come in here and you weld across here. You flip this piece upside down. Should still fit in there just fine. And weld the second side. Hopefully it's good. We'll find out.